fire hydrants have been around since the 18th century. In earlier times, firefighters used fire plugs and Johnny pumps. As technology changed, it was believed that Frederick Graff was the first to invent what we now call a fire hydrant. Unfortunately, the Patent Office in Washington, D.C. burned to the ground in 1836, destroying all the patent records in the process. In 1863, Birdsall Hilly invented the modern version of the improved fire hydrant. Memphis Light, Gas, and Water supplies water to more than 26,000 fire hydrants located throughout the Memphis area. Objective of this program: to understand the dynamics of a fire hydrant, to reduce water hammer, to properly open and close a water hydrant. Dynamics of water. Water is incompressible. It will not absorb any energy it gives off by being forced to suddenly decelerate. Water hammer is caused by an abrupt change in the velocity of flowing water. Brown water is caused by the sudden change in the amount of flow in a water main. During normal conditions, water flows through the center portion of a water main. Because of friction between water and the wall of the pipe, it is easier for the center portion to flow than the outer portion. As the average velocity increases, so does the velocity of the water close to the wall of the pipe. As the water moves faster, it begins to kick up sediment that usually stays at the bottom of the pipe. The sediment gets stirred up and does not settle back down until the velocity slows. Once the sediment has been kicked up into the center portion of the pipe, it is now in the main stream of flow. This causes customers to call to report brown water. Opening and closing a water hydrant. The AWWA Fire Hydrant Standards Committee recommends that hydrants be inspected in the fall or in the spring. Open and close hydrants one at a time. Dry barrel water hydrant. The dry barrel fire hydrant consists of several components. These components are essentially a footpiece, a barrel, a bonnet, an operating stem, the main valve, and the drain holes. Drain holes are located in the footpiece and open when the hydrant is shut down, allowing the water to escape from the barrel and prevent freezing during winter. These drain holes are sealed off when water is flowing, preventing erosion around the shoe. Dry barrel hydrants must be drained to prevent the water in the hydrant from freezing during the winter weather, rendering the hydrant inoperable. Opening a water hydrant. To avoid causing damage to the hydrants and the water system, open the hydrant slowly, approximately 3 to 5 turns. Allow time for the air to escape from the hydrant barrel. Slowly open hydrant to the full position to check operation. Closing a water hydrant. Once the water is clear, close the hydrant very slowly. Some hydrants may not seem to slow down when you turn them. This means the hydrant may slam, have some slop in the stem, and make a thump sound when closing. This causes water hammer and could cause major damage to the water distribution system. This is why it is imperative that hydrants are closed very slowly. If air is being discharged, stand clear of the hydrant and allow the discharge of air before closing. Closure should be smooth and without significant resistance. Operate the water hydrant 1 revolution per second until closed. Drain properly to prevent potential freezing. After the hydrant is closed, back off on the operating nut about 1/4 turn. This removes the pressure from the operating nut and stem. The main valve will remain closed.
Good morning. I'm Manager Taylor of the Memphis Fire Prevention Bureau, and for what's commonly referred to as the Memphis Fire Marshal's Office. For just a few minutes now, we're going to talk about fire hydrants and the operation of them, the difference in a wet barrel versus a dry barrel hydrant, and we're going to go over the proper procedure for opening the hydrant, allowing it to run and get a clear sample, the proper way to shut the hydrant down and make sure it properly drains down, and we'll talk about the annual greasing of the caps and maintenance that's required for all hydrants, whether they're public or private. So here we have a regular everyday fire hydrant at the training center. This particular hydrant has two 4-inch outlets on it. A Memphis standard hydrant will have a 4-inch and two 2.5s. One problem that's seen a lot in different hydrants around the city is the location of the operating nut on the cap for the outlet. This needs to be 12 to 20 inches above grade. That's straight out of the NFPA 24, which is the standard that covers underground pipe supply and hydrants. Another question that seems to come up often is sometimes on the street you'll see an MLG&W hydrant repair truck fixing a hydrant that's broken, and then the next day you might see a Memphis Fire Department hydrant repair truck doing the same kind of work. And people think that that's a redundancy in the service, and it's actually not. The underground portion of the pipe and the supply and that part of the infrastructure belongs to Memphis Light, Gas, and Water. When the hydrant supply breaks the grade or the ground, then the top part, including the hydrant, belongs to the fire department. So it's a joint issue. So now we're going to go ahead, we're going to put our hydrant wrench on this particular 4-inch cap and remove it. You'll notice that I started out with the wrench on top of the hydrant, and I put it back on top of the hydrant when I was done loosening the cap. That's so I don't lose it at night. It's very difficult to stick that in your pocket. And on a fire scene, if you lay something down and can't find it, then you would have to go and get another one. So we're going to finish taking this cap off with our hands. Ordinarily, a hydrant would have a chain that holds this cap in place, and it would dangle right here, so you don't have to worry about setting it aside. To open the hydrant, we're going to go in a clockwise motion till we get water. We're not going to let it run all day. In a perfect world, you'd let it run till you get a clear sample. And for the sake of saving water, we're going to say that that's clear now. We're going to shut this back down in the reverse manner that we opened it. We're going to take our time and close it. We're not going to slam the hydrant shut, because when we do that, that creates a water hammer on the underground supply. And if it has a crack or a weakness in it, it's only going to expose that, and then this hydrant would be out of service. So we'll go ahead and shut this down. One thing we don't want to do is lock it in a closed position and snug it down as tight as it will go. That's a no-no. We want to back this wrench off till we find a neutral position in the top operating nut. Now we're going to come around to the side, and we're going to be able to look and see and listen and make sure that the water has drained back down to below the valve, because this is a dry barrel hydrant. It doesn't hold water in it all the time. The water is stored below the frost line. This is a dry barrel hydrant. I'm sorry, a wet barrel hydrant would have water all the way up to the top all the time, and you'll find those in Southern California, probably Southern Florida, where they don't have to worry too much about cold weather like we do here in Memphis. So we'll put the wrench back on the top. If this was our annual performance test, if this was a private hydrant in an apartment complex, we'd go ahead and look at the cap, make sure it had the proper black gasket in it. And you say, what difference does it make if it's black? The different colored gaskets represent a different thickness and a different use. So you want this to be a black gasket. We would take a brush and some grease. We would grease this cap. We'll put it back on just like in reverse order of how it came off. We would then tighten the cap just enough to keep it from coming up missing, if you know what I mean. And then we'd hold on to our wrench, and that concludes testing that particular hydrant. If you have any further questions about this, you can refer to Chapter 5 of the 2003 International Fire Code. You may have also noticed this bollard protection around this particular hydrant. This is covered in Section 312 of the International Fire Code. Thank you very much.